So climate sensitive urban planning looks at basically incorporates nature as a fundamental element to urban living. So most heat research will show you that the coolest areas in a city are the wealthiest areas. Increase public areas can increase, and also these areas can then not be concentrations of heat through asphalt, but areas of cooling instead through water bodies or green bodies, etc.
Cities today are heating faster than their surroundings, not only because of climate change, but because of how they're built. Research shows urban areas can be up to 5.6 degrees Celsius warmer than nearby regions. Roads, concrete surfaces, and dense construction absorb heat during the day and release it slowly at night, preventing cities from cooling down. This is known as the urban heat island effect. And it means that during heat waves, cities begin from an already elevated temperature. So today we're asking a fundamental question. Can cities be cooled through design instead of dependence on air conditioning? And we have with us urban planner Sana to define what we mean by climate smart design, because in most places, conventional planning still prioritizes plot sizes, road widths, and construction speed without mapping heat pockets or protecting natural cooling systems. When we talk about climate smart urban design, what does that mean in practical terms, and how does it differ from conventional urban planning?
Urban planning conventionally has looked at building codes, square footage, plot usage, road widths, infrastructure regulations. And what that means is it hasn't necessarily looked at ecosystems or looked at nature as a very viable component of urban living. So climate sensitive urban planning looks at basically incorporates nature as a fundamental element to urban living. So this means planning would be done with intelligence regarding where, for example, the largest heat pockets in in urban space are, or how to manage and regulate heat, or figure out insulation for housing units so that it doesn't create emergencies, especially during increased periods of heat, which is what the global world now has moved towards. Increased heat, increased periods of extended heat in that way, or also other natural elements such as water. Where does water surface runoff take place? How is it being incorporated in infrastructure? Are urban, is urban infrastructure basically blocking where water runoff needs to take place? Things like that. And then also looking at what naturally existed in a land, like wetlands, trees, marshes, things like that. Climate sensitive urban planning would look at what natural elements exist in urban space or what don't anymore, and how they need to be incorporated so that we can mitigate the extreme effects of climate, basically.
If geography alone explained heat, rural areas nearby would feel the same temperatures, but urban areas consistently record higher exposure. So then what makes cities across South Asia, Africa, and Latin America particularly vulnerable to rising temperatures?
So the regions that you've mentioned, they basically they, by the virtue of their location, they are warmer. They are either closer to the equator, or they're located in certain with a certain kind of landscape that already was warm. But it's not, but just this, for example, their geolocation isn't the only thing that impacts the extreme effects of heat that they're facing, because even rural areas close to the equator, they're not as hot as the urban areas are. And the reason why urban areas are so much hotter is because of the building materials that they use. So a large component of urban areas is roads for cars, which means that you have asphalt that traps heat, and it radiates that heat during the night. So in the morning, it's capturing so much heat, and also it continues to release that heat over the night, which means that there is no period for that area to cool down at all. Also, then you've got, for example, what's being used on those roads our cars. The emissions that come out, the emissions are not just pollutants, which also impact heat, but also heat in itself, right? So that's what that happens. And you've got asphalt as a primary ingredient in that infrastructure, not just for roads, but then also you've got concrete for all other building materials, which also traps heat and is not really conducive to cooling infrastructure. And then also you've got high-rise buildings now in most urban spaces, especially where you've got a lot of density and mass populations. So they use, for example, glass, which also once again radiates heat or increases the temperature by virtue of its internal components, right? These are all major elements or the majority elements of what urban spaces include, and they are not conducive to cooling infrastructures in any way. They all increase and encourage heat. So then you've got these, what you create basically are urban heat islands, where you don't have the kind of vegetation or natural infrastructure that used to exist to cool a place down. And whatever did exist is also being removed in the process of urbanization. So, for example, trees will be cut down or marshes will be covered. If there are small rivers that are flowing or tributaries of any kind of water body or storm drainages, they will be covered up, etc., so that more land can be used for profit, essentially, for capital gains, because that's where you will have your business buildings or residential housings that are maximizing profit per square meter as opposed to comfort and livability in that way. These areas also, specifically in the global south, they don't have, the reason why they're also extremely, where you'll find them in the headlines more than other places, is also because the kinds of the kind of climate that they are already used to, the baseline is already a lot. So when climate increases, when temperature increases, then that's why it's so much easier for these regions to face extreme events, because they were already kind of high to begin with. And they're also usually poorer areas, which don't have the type of capacity that you require for emergency services or cooling infrastructures for public welfare and emergency responses in that way. Because of all of these reasons, and also because they're high density areas that usually require fast development for mass housing. So, for example, informal settlements will usually pop up in these places. They will not be according to any kind of code. And the kind of materials they'll use, for example, metal slats for roofing infrastructure, right? They all trap heat and become extremely hot ovens normally in a summer. Or even spring. And also, there's no variation of climate as such that provides that kind of relief that you would have in areas in the northern hemisphere that see more seasonal changes, etc. So all of these things make these regions more vulnerable to climate, to extreme climate, basically.
Cooling cities is less about technology and more about scale. Even surface interventions like cool pavements can reduce temperatures by 8 to 10 degrees Celsius, and small drops at street level can significantly improve human comfort. Welcome back. If heat is being engineered into cities, then cooling has to be engineered back in, and not only through machines. Air conditioning does cool indoor air, but at city scale, it can also feed a loop. More AC means more electricity demand and more waste heat being pushed outdoors, which warms the surrounding air and increases the need for more cooling. The alternative lies in passive cooling, design choices that reduce heat before it enters buildings. Evidence shows green roofs can be around 30 degrees Celsius cooler than conventional roofs, while reflective or cool roofs alone can lower indoor temperatures by about 1 to 2 degrees Celsius, enough to reduce heat stress. So we asked Sana the most direct question: if air conditioning can't be the only plan, what replaces it?
Cities that use or are completely reliant on ACs for cooling actually end up in a chain where more cooling is required because while ACs cool an inside location, they're actually emitting a lot of heat on the outside. So the outside is becoming warmer and warmer because of those air conditioning emissions. And so, for example, Gulf countries, they largely rely on highly sealed glass components and then air conditioning. And that's extremely energy inefficient and also extremely energy intensive. And that's not sustainable anyway, especially when you look at the nature of Gulf countries, when they are water scarce in the first place, they're using so much energy just to cool themselves down when the infrastructure, the materials that they've used are completely, they don't suit the place at all. Historically and traditionally, natural materials have always been used to create the require um, to create what human habitation really needs. So, for example, in cities in Morocco, you've always had courtyard inclusions. You have water body inclusions in everyday living spaces, so that there's a cooling effect that's in place, and also buildings are oriented to where the wind direction flows from. So this way, um, a natural cooling system is in place. Otherwise, any place in Pakistan or India has, or even around the world, really, you've used earth materials, so clay, limestone, or lime to use as sealing agents, so that there's a very lovely and soft kind of atmosphere throughout the year. It's cold when you need it to be when you need relief from extreme heat outside, because heat isn't trapped on the inside, and the material that you've used to create your house isn't essentially making your house into an oven. Today, the kinds of when you just use concrete and metal beams to create your housing or building infrastructure, you have essentially created a place where there is no insulation that's being accounted for when it comes to cooling or ventilation. So, at any time when you have a heat wave going on, if you look at the hospital, if the patients in the hospital, majority of them tend to live in the top floors or the topmost floors of apartments and buildings like that. And that's because these buildings, they trap heat. So what is the alternative? That it's always existed. It's not something that you need to invent again, because the technology, when you think about technology, you think that you need to create something that's high tech or requires a lot of investment. And it's not like that. There's plenty of evidence to suggest, or historic experiences to suggest, that natural materials actually are a lot more climate friendly and create better environments for people to live in on the ordinary. And those are the materials that have now been replaced by concrete and other carbon intensive materials. So concrete isn't just trapping heat, it's also extremely it's expensive for the earth to produce these things. So in its supply chain in itself, a lot of carbon emissions take place. And when you look at them on like a dense scale, where you have a city that's a metropolis and everyone is using the same kind of, it requires the same kind of building materials, then it looking at it at scale, you can see how many millions of tons of emissions take place just because these materials need to be produced. And the alternative, which would be natural elements, are a fragment of that. So not only are those natural materials better in the work that they do, in terms of providing cooling or providing heat insulation, they're also a lot less expensive for the earth to produce in that way.
Then we narrowed in on the mechanics of passive cooling, how you position buildings, how you move air through them, and how you prevent heat from entering in the first place.
Some of these measures are being adopted globally, but there are a few major hindrances for cooling infrastructure, such as cross ventilation, to be incorporated. So cross ventilation is probably incorporated in many building codes in cities around the world, because this is an essential understanding. When first densely populated cities were popping up, some problems came about, right? Like people could tell that, okay, if I have a building on like the sixth floor and a new construction is now taking place right next to me, and that blocks access to my sunlight and my wind, it's not just that I am inconvenienced by the lack of sunlight and wind for aesthetic reasons. It's a very big health, safety and safety measure as well. So building codes have always incorporated, for example, heights and distances and aspects of consideration for wind channels. So we know that southwest facing houses or gardens are a lot more desirable, not again for aesthetic reasons, but because they have very practical impacts on how urban habitation is impacted, right? So in that way, codes do take account of a lot of different things. But when it comes to understanding climate on like a holistic level, that's where it lacks. That's where it's not essentially taken into consideration. So building materials that are like nature-based, they're not incorporated into urban codes for a few reasons. One of which is that so far, these nature-based solutions haven't been tested on for scalability when it comes to vertical expansion. And urban living requires vertical expansion, right? So there is a lack of political willingness to figure out how to make our cities more climate friendly. And also, there is a lot of political pressure because the supply chain is it's capital intensive and it produces a lot of profit for people who are essentially a part of what the city code material is. So the concrete industry, the timber industry, etc. This is how there's also a lack of political willingness that you see kind of hold people back against implementing or going for these kind of solutions, because it's, once again, the research has always existed that this is what is more sustainable, but the urban space is rapid, and because of that, there are lots of obstacles that come about when it comes to implementing these things. But you don't have to look at it in like a hopeless way, that a city is so chaotic that there's no way to do these, to adjust it, or if it's going to be expensive to do that. Retrofitting is usually a lot cheaper and more sustainable than creating a new development that would be, perfectly climate sustainable or adaptable. Lots of public land, amenity plots, government offices, etc., can be the first ones to implement these things at a very low cost. But there's a big lack of political willingness in countries that have climate adaptation as like a priority that they do implement on, because again, codes can be made and they are made, but implementation is difficult. For example, in I think around 2016, Ahmedabad was facing extreme heat and had a lot of fatalities happen in the city. So the municipal corporation, with researchers, they devised a heat action plan that they implemented the next time there was a heat wave. And they saw, because of that, immediately less fatalities occur. And that is, to me, worth it, right? You devised a plan, you implemented it, and you saw results that were actionable and also scalable. So this heat action plan now goes to different cities. It goes to different cities. It's been adapted in their building codes or their master plans, but implementation is what is lacking. Where implementation takes place, for example, in Singapore, where building codes are enforced with authority and with regular maintenance, thermal conditioning is much better now. Their building codes now state that there must be vertical greening ensured in any kind of old or new construction, and that has changed the overall temperature of the city, right? And there are many examples across the world. For example, in Medellin, in Colombia, green corridors were implemented, and they also immediately saw massive results, especially across those corridors. but then also citywide. And even the difference of 1 or 2 degrees is the difference between life and death. And it's also the difference between a collapse of an ecosystem or the ability to sustain one, right?
Many of these solutions are neither new nor experimental. They rely on airflow, shade, and material choice, principles long understood before mechanical cooling became standard. Welcome back. Heat is a public health risk, but it is also an inequality problem. Across cities studied globally, the pattern repeats. The coolest areas are often the wealthiest, more tree cover, more parks, more setbacks, more shade. The hottest areas are frequently low income neighborhoods that have fewer cooling buffers and more heat trapping surfaces. In informal housing, the gap is even more severe. Evidence shows unshaded metal roofs can push indoor temperatures 5 to 10 degrees Celsius above outdoor levels during heat waves. Some dwellings have been recorded running 8 to 12 degrees Celsius above outdoor temperatures, holding heat late into the night. That turns homes into exposure cities, especially for children, the elderly, and anyone recovering from illness. But the hardest question is the one most cities struggle with. How do you make climate smart design inclusive?
So most heat research will show you that the coolest areas in a city are the wealthiest areas because those are the nice neighborhoods where you have a lot of deep tree coverage or access to parks nearby or even water bodies, right? So water bodies, parks, trees, all of these mean cooler areas. So wealthy people already get to live better lives by virtue of their position in a city. And then they have access to ACs or cars, which make the climate more vulnerable, of course, for those who are already vulnerable and don't have access to luxury like that. So when we talk about climate smart urban planning, it's again not high cost; it's low cost, and it defaults to nature-based solutions, which are not meant to be exclusive to the wealthy. So, but right now they are. Right now, the materials that can be used at scale in an urban setting, they're cheaper when they are manufactured and readily available, right? So that's why you have metal beams or steel caps or just concrete that's being used in these informal settlements, which are being made, which are being built without any, adherence to any code, of course, or consideration for building safety, let alone climate safety in that way. So, how can this happen? How can we ensure a more socially equitable, climate friendly city? This has to be done through the municipal governments. This has to be done through an enforcement of safety, but not to dismantle those urban settlements, which are very necessary for cities, which don't provide adequate housing or social housing for everyone. How do you sustain those people and their buildings? It would be a matter of taking the political will to provide those materials from the supply chain to make them available. And then also to, once again, at the city level, see how you can scale them vertically, because that's what's necessary in these realities. We cannot scale horizontally anymore. The cities are already massive and have expanded too much. And those are even more unsustainable because they have a higher dependency on grids that don't service them, water bodies, etc., or water supply. So that has to become available. That's an infrastructure level. But then also, cities need to provide public spaces for shade and cooling areas. So, a lot of, for example, in Pakistan or the global south generally, a lot of the population is highly exposed to the climate, right? So, you may not have offices where everyone works from. Many people work from the street. How have the streets become uninhabitable for a person to be there? Why are they mainly habitable just for cars? There is no shading infrastructure, and whatever natural shading infrastructure might have been there, trees are usually cut down to make wider pavements or wider, roads or buildings, etc. So the public is exposed to extreme heat from not just inside their house, but also outside of their house. And providing arcades, providing shade and ventilation is a lot cheaper But even that isn't necessarily done. And if that is done, then it provides access to a whole population to a better climate that they don't necessarily have. Because even malls, some of the only places with AC or cooling areas available to the public, are also very exclusive. Not only can everyone not afford to be there, but even as just a place where you can loiter, it's not allowed. You have security and you take people away. So where do people really go to calm their bodies down when they're facing severe climate, impact? And those cooling stations aren't available, but they can be in any public space. And it has to be also done through a very intelligent system of information, which is provided to people who don't necessarily get access to these things. It's, for example, through community referral systems where you inform everyone what the impacts of extreme heat are. Because extreme heat is so dangerous and deadly because you cannot see it. For example, with water, you know the water level is rising and you are in danger. When it's extremely hot, you think you can take it, or your body is just going to get through the day. It's not. Fatigue and exhaustion are just minor parts of it, but the impacts are deadly, right? People faint and they have no idea they're about to faint at all because they cannot catch the symptoms that they're facing. So the awareness for these things is as necessary as infrastructure, but of course, infrastructure is more necessary in that way.
One takeaway is hard to avoid. Heat resilience cannot be designed only for premium neighborhoods or new developments. It has to work where people actually live, including informal settlements and low income housing. Because that's where the risk concentrates. Welcome back. Cooling a city is not a single project, it's a governance decision, repeated across years. What you permit, what you protect, and what you enforce. The reason city scale results matter is that small pilots don't change the lived reality of a heat wave. Cooling shows up when a city combines interventions such as shade, greenery, reflective services, water sensitive planning, and transport reform at scale. And there are examples where design reduced heat without simply increasing energy use. Medellin's green corridors are linked to roughly a 2 degrees Celsius temperature reduction. Barcelona's superblocks, which limit traffic and reclaim public space, are projected to lower temperatures by about 1.2 degrees Celsius on hot days. Ahmedabad's heat action plan shows what coordinated planning can achieve, helping reducing heat-related deaths significantly. What evidence exists on the effectiveness of green spaces and water bodies as natural coolers, and why do cities still struggle to protect and expand them?
Parks, water bodies are, of course, cooling infrastructure that's naturally available. But not all parks. That has to be made clear because the kind of urban park we have right now, which is just grassy, it's better than concrete, of course, or asphalt, but it's not necessarily doing that much for the environment. You need biodiversity. So a park which is not just grass, but has different kinds of trees, different kinds of plants, shrubbery, etc., that is an effective cooling infrastructure. So what evidence is there to suggest that these provide cooling for the city? There are so many studies. There is no debate on this. They do. It's a fact that a water body will cool the space down, and so will trees, and so will shade, and so will anything that's not a hard heat absorbing material like concrete or asphalt, like the grass and earth. So, of course, they are cooling infrastructures. Why are cities not paying attention to these? It's to me, this is elite capture of capital because there's only an interest in maximizing profit when it comes to a city. You want to maximize square footage for revenue generation, so you construct more buildings that are carbon paste, cut and paste designs that are once again not necessarily adhering to any kind of climate sensitivity. They're just easy to construct because the model is available and you can stack them neatly and create more and more of them. So that's where any kind of focus is. Or when it comes to the street, the understanding still, unfortunately, for most cities is that making bigger highways, making bigger roads, freeways, flyovers, underpasses, etc., is what's necessary for street design, as opposed to understanding that it's only when you look at it holistically do you solve both traffic and congestion problems and also climate issues. For example, in Barcelona, which is one of the best examples in the world, there is a super block structure. So that thoroughfare can be reduced, and those super blocks that are created in across the city, they consist of permeable pavements or trees, and plants and water bodies, and they provide cooling throughout the city. So a city like Barcelona, which could be a lot hotter, is not as hot anymore. So that example is readily available. And many cities across the world are now finally also realizing how damaging the current standard is for in terms of the material that is used for city construction, but also decisions that are used to create more flyovers. They're being destroyed. They're actively pulling down these flyovers so that pedestrian areas can increase, public areas can increase, and also these areas can then not be concentrations of heat through asphalt, but areas of cooling instead through water bodies or green bodies, etc. So you need a blue infrastructure and a green infrastructure to go together. And they immediately provide cooling. On a small level, on a very small level, you can look at any kind of old house that would be constructed in North Africa, for example, where you would have a courtyard, but a courtyard with a fountain or some kind of water body. And even in extreme heat, natural heat, those houses are very cool. You will never feel the effects of how hot it is unshaded outside in that way.
Are there global examples where cities have successfully reduced heat stress through design rather than energy use, and what lessons can others apply?
I've already mentioned some examples like Barcelona, Colombia, Singapore, etc. So these are cities that are already doing this, and there's so many more across the world that are paying attention to the consumption of energy in that way. Yeah, these are the
I'm really, really sorry. I think I repeated my question. I wanted to ask, I'm really sorry. How does transport planning affect the urban heat? For example, through wide asphalt roads, flyovers, or car-centric development patterns? This is something I wanted to talk about.
Yeah, this is also something I've already kind of explained, but even within the question, the answer is there. Transport planning right now caters mainly for cars and private vehicles, and that means more and more asphalt is poured across urban areas, which traps heat, but also, again, cars emit heat, cars emit pollution, the pollution is trapped in the air. In areas in South Asia, for example, anywhere in South Asia, you already have a large component of dust in the atmosphere that, combined with pollutants, creates an ecosystem of heat being trapped when you have extended periods of heat already, because we tend to just have those kinds of weathers in these areas. The asphalt is the most damaging part of it. And when all effort, all energy, all expenses within the supply chain. So when you think of asphalt, do think of it from the start of how it's created, because of how carbon heavy it is in terms of its creation in itself, and then also the constant emissions that take place. It's a cycle that reinforces a very destructive kind of situation for urban areas. And that's what you see in most places that have not considered any kind of climate adaptation. So Karachi, Lahore, Islamabad, Delhi, Mumbai, these are cities that face extreme heat, extreme pollution, and they haven't necessarily done much to cool their cities, because the modes of transport, when I talk about Pakistan specifically, there has not been the kind of investment you need in green corridors. In fact, in Karachi, to even create the BRT, the trees that lined those roads were cut, and those were older trees. And within their plan, they said they would plant new trees. New trees are not as strong as old trees, of course. They are saplings. And this cannot be done retroactively. You need to plant trees first, and then, if you must substitute it, you can cut the older tree that you're replacing it with. But that hasn't been done. Tree coverage was already minimal, and it is completely being eroded and eradicated. There's deforestation everywhere, from mountains but to urban spaces as well. Even mangroves are cut, and there's no good reason to cut a mangrove ever. There is not a single good reason to cut a mangrove. If you must cut a tree, you must ensure its replacement, and that's not done either. And then when you have a transportation system which is so reliant on motor generation, so you have motorcycles, you have private cars, trucks, etc., but the same kind of investment is not made towards public transport that is a lot less energy intensive, which is more cooling friendly as well, because you can move that to an electric grid network. You can encourage shaded pathways so that bicycles are more practical in these areas, because in large urban areas, you don't need to be in a car. You really don't. It's not natural to use a car to go somewhere so close by. We do it now because that's what the reliant road network is, and the alternative is a very poor kind of alternative for anyone to want for themselves, because you're exposed to extreme heat and pollution, so you don't want to do that. If you look at any kind of investment, large-scale investment within transportation in Pakistan, there are instances, of course, of BRTs and green lines, etc., across urban areas, but not at the same pace, frequency, or intensity as road networks, which are also being rebuilt constantly because they're not being maintained in the first place. And if you only look at transportation networks when you think of roads, when you think of transportation networks, when you think of roads or private cars, you're forgetting that water is a way of transport as well. And when there is rain, and all land has been encroached for roads and cars mainly, then the transportation network that's being blocked is water runoff, and that erodes that asphalt, which is then there's a need to repot the roads, etc. So more dust flies into the atmosphere, creates more heat, lung issues, etc. Makes a lot more people vulnerable, especially those who live next to large transport ways. It's a cycle that goes on, but I've answered it throughout the questions. I would say there's and within your question itself, like the answer lies right there. The investment is within carbon intensive options, as opposed to anything that would be conducive to something that's not carbon intensive or emission intensive. There's no investment in walking infrastructure in the same way. Wider pavements are needed for pedestrian pathways that are also permeable. So you could have vegetation that lines them, trees that line them, provide shade. And if not trees, even if you don't want to plant trees, which is of course the best option, there are still many ways to provide shade through different kinds of shading infrastructure that's very, very low cost. Even cities like Sevilla in Spain, which are right at the points of the planet which incur a lot of heat, they've planted shading infrastructure across streets that are 40 to 45 degrees on average, and the person and a pedestrian can still walk through them and not suffer any kind of fatality, because that exists over there. In our cities, in our part of the world, there's no consideration for that, because people are not going to walk if there's a road. People are going to walk out of necessity, but people will want to walk more when the infrastructure for them exists. When it's cooler to walk, you want to take a bicycle, you're more active. It's so much better in every kind of way. And it doesn't require so much. It's also a myth to think that making cities more walkable and green is more expensive. It's more expensive to continue doing things the way we are right now. It's more expensive for the planet. It's too costly for the planet. The planet can't afford it anymore. And our bodies, the human body, is also at capacity. We're now constantly suffering from the wet bulb effect, from urban heat islands, etc. So the fatalities speak for themselves. But there's also numerous different kinds of diseases that are now frequent. So it's disastrous in this way to continue.
Here's the line that matters. A hotter future is being locked in by global emissions, but urban heat is being amplified locally by design choices. That means cities have agency. You can choose whether streets work for cars alone or for human bodies in summer. You can choose whether shade is treated as an amenity or basic public infrastructure. You can choose whether building codes are enforced as safety standards or treated as suggestions. And you can choose whether public land becomes a heat trap or a cooling network. Cooling cities without over-relying on air conditioning isn't about nostalgia or older architecture or romanticizing courtyards. It's about using evidence and then building the city that evidence demands. And with that, we end this week's episode. I'm Mahin Azam Khan. I'll see you next week. Until then, Khudafiz.